Good morning, friends. Welcome you all for today's session. In this session, we'll be studying about Euler's formula for buckling of a column with one end free and other end fixed. Right, so this is the last case which we'll be studying. So let us start with the video session. So I need to draw a beam which is vertical, or you can call it as a column, such that its one end is free and other end is fixed. So let me consider a column. Let us say this is the column what I have considered, right? So its one end should be fixed, so I'll show this as a fixed end. Let me show this as the fixed end. Then other end is free. So if other end is free, let me slightly increase the length. Okay, now how will be the final deflected beam due to buckling? So since it is fixed here, up to initially up to few centimeters it will go hand in hand, then thereafter it will, right, buckle like this. Now the total length, I'll take it as total length here, I'll take it as L. As usual, there are no changes in this. Total length is L, and at a distance of x, at a distance of x from the bottom, so I'll just mark a section over here. So this section I'll call it as xx. So this distance here, from the fixed end is taken as x. Right, I'll take this as x. Now the deflection at the section here, I'll take this as y. Right, so initially there will be some load here at this particular point. ये जो वो आपका vertical beam और column दिख रहा है, right, your compressive loading will be acting here at this point, which gives a reaction which is equal and opposite here also. So here I'll mark it as P. Now initially it was acting here, but just because the beam got deflected, the load I can show it here also. Right? So the load comes here because the beam has got deflected. So it is P. So deflection here, this distance is A. This distance, top distance is A. Here the deflection is Y. Right? Now try to understand what is happening here with respect to this section XX. We are having a P at certain offset from the main column, so that offset distance is Y. So what is the moment caused at a section? Moment caused at the section is P into Y. P into Y, right, up to the section. And if you consider here the moment at the top, it is P into A. P into A, right? So there should be some resisting moment here which will avoid this buckling. ये जो deflection यहाँ पे हो रहा है, if you want to avoid this, then I should have some resisting couple here at the fixed support. अब इसका direction क्या होगा? You can just check out P into Y. It is in anti-clockwise direction. Anti-clockwise direction में move हो रहा है. So here this will be in clockwise direction. Right? So this I'll take it as M. Right? So once if this is clear, then things are very easy. It is just about substitution, applying the boundary conditions and getting the results. Right? So as usual, deflection is equal to moment caused about section XX. So I'll start from the same point. We know that deflection is equal to moment caused about the section XX. Right, so moment here, deflection here is E into I, d square y by dx square. अभी देखेंगे moment. So moment caused is P into Y. So this is P and this deflection is Y at section XX. So it is P into Y. It is anti-clockwise. जब भी anti-clockwise आएगा, I'll take it as negative. And plus yum, plus yum. Right? So you can also just check it here. I have taken the distance from the bottom, so I need to take the bottom loading, not the top loading. जब भी आप section नीचे के support से ले रहे हो, then you need to consider this load P. So it is P into this distance Y. So P into this distance Y कैसे rotate हो रहा है ऐसा, like this it is rotating, right? P with respect to this Y, it is rotating like this, which is anti-clockwise, so it is negative. Opposite to that, you are having a positive moment, which is plus m, so it is plus m, right? So therefore E into I d square y by dx square plus y, you take it this side, plus py is equal to m, is equal to m, right? Now what I can write here is the same thing what I had assumed previously. Let beta square is equal to P divided by E into I. So if you want to put this value P divided by E into I, then I need to divide this entire equation by EI. So therefore d square y by dx square is y double dash plus P divided by EI into y is equal to m divided by E into I. Right? So if you put the value of beta square here, so therefore y double dash plus beta square y is equal to m divided by I. What is this value of m? So m is the restoring moment caused because of this P into A. So P into A, you need to take it as a positive value because its magnitude of m is equal to P into A. So it is P into A divided by E into I. So R एक बार y double dash plus b square beta square y is equal to P divided by EI is once again beta square, right? So P divided by EI is beta square. So here you are having, so here once again it is P by A. P by A is, sorry, P by EI is beta square. So it is beta square into A. Right? So ये हो गया आपका differential equation for which you need to find out the solution, right? So the solution to this differential equation is given by the solution to this differential equation is given by, so this you need to remember, y is equal to a cos beta x plus v sine beta x plus a. Once again I'll mark it. So a cos beta x plus b sine beta x plus a. So this is the general solution. So you need to keep it in mind. Now I'll be applying the boundary condition. First I'll apply boundary condition number 1. So that is at x is equal to 0, y is also equal to 0. Right? So at x is equal to 0, y is also equal to 0. So if you put it in this equation, y का value 0 हो गया. So it is a cos 0 plus b sine 0 plus a. So what is sine 0? Sine 0 is 0, right? Cos 0 is 1. So therefore value of a is coming out to be minus a. Right? ये पहला वाला boundary condition हो गया. Next I'll take for boundary condition number 2. So what is boundary condition number 2? At x is equal to 0, y dash is equal to 0. at x is equal to 0, x is equal to 0, y dash will be equal to 0. For that I need to find out the value of y dash. You need to differentiate this, so therefore y dash is equal to a cos x derivative is minus sin x, so it is minus sine beta x into beta plus beta sine beta x derivative is cos beta x into beta and other side it is 0. Now यहाँ पे y dash is equal to 0 according to the boundary condition. It is minus a into beta. If you put x as 0, it is sine 0 plus beta into b into cos 0, right? So here in this condition this will become directly 0. Now cos 0 is 1, cos 0 is 1, so what I'll be getting here is b into beta will be equal to 0. So therefore b is equal to 0, right? So it is ab is equal to 0, so either a should be equal to 0 or b should be equal to 0, or if you take beta into the numerator, sorry, into the denominator, so 0 divided by anything is 0, therefore the value of b will be equal to 0, right? So once if you are done with this, next we'll be going for the last boundary condition. So I have got two constants and I have got the values of a and b, so don't go for the third boundary condition because it's of no use. I already got the two values, so let me write the differential equation. So y is equal to what I'm getting here is a cos beta x plus b sine beta x plus a, right? So this was the equation, but here what values I have got? B is equal to 0 and a is equal to minus a, right? So this we got it, so therefore y is equal to, so when b is equal to 0, this is a cos beta x, b value will be 0 because 0 multiplied by anything is 0, a will be written as it is, so y is equal to value of a is minus a, so minus a into cos beta x plus a, so therefore this will be your equation number 1. Now I'll take the third boundary condition 3. So what is boundary condition 3? At x is equal to L, slope will be equal to 0, right? But in this case, which is a unique case, so be careful, many times you take it directly, so this is not the case. Here there is a slight difference, so you can just check it here. At x is equal to 0, I'll take this point as L. At x is equal to 0, y value is a, right? So this I'll take it as 0. At x is equal to 0, y value is a, so y value should be a. Therefore equation 1 becomes, so what does equation 1 become? A is equal to minus a cos beta L plus a. So a and a can directly cancel these, so therefore a cos beta L is equal to 0. So what it implies, a is a constant, it cannot be equal to 0, so therefore cos of beta into L is equal to 0, right? So cos theta is equal to 0, इसका मतलब क्या है? It simply means that theta is 90 degree. So here theta is beta into L is equal to 90 degree. Now you put the value of beta, but beta square is equal to P divided by E into I. So here, if you square here, so it is beta square L square is equal to pi square divided by 4. So beta square value, put the value of beta square. Value of beta square is how much? P divided by E into I into L square is equal to pi square divided by 4. So therefore P is equal to pi square EI divided by 4 L square, and that is equal to PCR, critical load, which will be causing a buckling in a case where one end is fixed and other end is free. Right, so that's it for today's session. I request you to go through all the 4 derivations, practice them thoroughly, and then in the next session we'll be going with the numerical part. Right, so that's it for today's session. Have a great day. Bye bye. Take care.